In this video, I'll be solving this AP Precalculus free response question that was given in their old course description. I think it was like the preview of AP Precalculus before it was the actual course. And this was just a sample question in the end of the manual or the documents. And they did not give an answer. So I'm here to solve it for you if you're looking for a solution. Or it's just good practice too if you just stumble upon this video and you're studying for AP Precalculus. So I encourage you to pause the video to solve this problem first, if you have not already, and then unpause to watch me provide my thought process and solution. Okay, and well, I'll actually complain about the third part also, that it's not a valid problem. So at least for the grading point of view. So pause the video first to work out this problem for yourself, please, if you have not already. But okay, so I'm going to read this. A wheel has a diameter of 0.8 meters, rolls on flat ground at a constant rate. The wheel completes a full rotation every 4 seconds. Point P is located on the wheel, where the wheel is touching the ground at time t equals 0 seconds. As the wheel rolls, the height of point P above the ground periodically increases and decreases. The function h gives the height of point P at time t seconds. Sketch a graph of y is h of t for 2 full rotations of the wheel starting at time t equals 0. Label axes and appropriate tick marks on the axes indicating max, min, start time, end time. And then part B, I'll even read right now, it says write a sinusoidal function model of this form for the scenario. Provide a rationale for each value. And then this part I'll skip later. So the reason I read part A and B first is this already tells us it should be a sinusoidal function, or cosine or sine. Technically, sine and cosine are just shifted versions of each other, so to model it, you can use either, but in this case, it tells us to model it with a cosine. But we know that it's going to be sinusoidal in nature, so there's going to be an amplitude and a period that we need to find. Those are the key points for a sinusoidal function. Okay, so how do we get that from what they give us in the problem? So, in terms of amplitude, it has to be somewhat related to the diameter. They tell us the diameter is 0.8. So from this bottom point to the top point, it would be 0.8 meters. That's not the amplitude though. We'll get back to that. But we know if we're sketching this graph, so let me label my axes. This is h of t. This is t. Okay, and then if we say at the ground, it's at h equals 0. Okay, so I'm going to say t is 0 over here. Then the maximum point, so that's the minimum point. The maximum point is this diameter, which is 0.8. So we can label those two right there. Okay? Again, it's not quite the amplitude. We'll get to that, but this helps us to get the min and the max of this curve. Okay, now what about the horizontal portion? How do we figure that out? Well, it tells us that a wheel completes a full rotation every 4 seconds. That's the period right there, 4 seconds. Because period is when it starts repeating itself again. So when it rotates once, let me shift this down again, it's going to repeat the position, the height again, the next rotation and the next rotation. Okay, so period is when it starts repeating itself again. So just emphasizing that. So that's at 4 seconds then. So they ask us to sketch 2 rotations, so 2 periods. So if 1 period is 4, then 2 periods is 8. Okay? And as we said, at t is 4, it's going to repeat itself at this point again. At this point, the height is 0. So we can label those points already. So at t is 0, the height is 0. At t is 4, the height is 0. At t is 8, the height is 0 again. Okay, and then you can just intuitively think halfway through the rotation, so at t is 2, is going to reach the maximum point. And same thing between 4 and 8, halfway in between, that's 6, is going to reach the maximum again. Okay, and then we just sketch a sine-looking curve, like something like this. My pen will cooperate. Something like that. Okay, this is a good enough sketch, in my opinion. Okay, so Part B asks us to model this in the form of h of t is a cosine b times t minus c plus d. Okay, so since we're asked to start with cosine, how does cosine look? So if I just draw cosine of t, how does that look? It looks like this. Okay, so it starts at the max of 1, and then it goes to, it starts at the max of 1 and then it decreases. So in our case, it starts at the min and then it increases. So it looks like ours is a reflection of cosine t. Hopefully you can see that one more time. Cosine t, it starts at 1 and then it decreases. 1 is the max. In ours, we start at the min and it increases, so it's the complete opposite. So maybe we want to reflect cosine of t to match ours. When we reflect, that has to do with a, so a has to be negative. So let's say a is less than 0 because h of t looks like a reflection of cosine of t. Okay? So a is the amplitude. Also, that's just how sine and cosine are modeled. With the a in front is the amplitude. So what is the amplitude of this guy? So here I was saying the amplitude is not 0.8. Amplitude is with respect to the average value. So the average, I'm writing in pencil over here, is 0.4. So with reference to the average value, how much it goes up and how much it goes down. In this case, it would be 0.4. Okay, absolute value, sorry. We said a should be less than 0 because it's a reflection. So a is negative 0.4 as a result. Okay. So that takes care of A. Let's finish up the vertical stuff first. That's D again. This is shifting it up or down. So we took care of A, which should have reflected it. Okay. So let me even sketch it over here. Minus 0.4 cosine of t. How does that look? That would look like, so this would be minus 0.4. 0.4 look like this. So I'm not going to draw the time axis. Looks something like that. Ours looks like it's shifted up. By how much? By 0.4. You just shift everything up by 0.4. The max would be 0.8, right? 0.4 plus another 0.4, that becomes 0.8. Minus 0.4 plus 0.4, that becomes 0. So D is 0.4 because we need to shift up by 0.4. Okay? So that takes care of A and D. Now, B and C has to do with the horizontal portion. Okay? So, let me work on this piece of paper now. So, I'll try to fit it both on camera when needed. I'll just have to zoom out. But anyway, so to get B and C, B is the period. Has to do with the period. It's not, in engineering terms, we call it the angular frequency. But that's omega. So if you remember, if we have the form cosine of omega t, omega is 2 pi over capital T, where capital T is the period. In the earlier problem, we were saying that the period is 4. So 2 pi over 4, which is pi over 2. Okay, so B would equal to pi over 2. Okay, and then is there any shifting to do? Horizontally, there isn't, because we started with the cosine, and we just did some reflections in order to match it. We don't have to horizontally shift it anymore. So C would equal to 0. So our final answer, h of t, would be minus 0.4 cosine of pi over 2t plus 0.4. That's our model for, at least for the curve that I sketched. So this is not a good problem because there's an infinite amount of solutions for this and for this technically. Well, not so much because this asks you to start from t0, but you can choose your height at, you don't have to make h as 0 here. You can make h as like, I don't know, 1,000 if you really want to make your life a little harder. It's more intuitive to make it 0, but technically, since you don't say that at this point at the ground h is 0, you can make it any number you want. So it makes their life harder to grade this problem actually, but this is my model for the one that I sketched. Okay, now this is another bad question in my opinion. So I'll do it the way that they probably intended to first. On the graph in part A, label a point on the graph I at which the function is increasing and label a point D at which the function is decreasing. Then in part C, indicate whether the values of the change in the rate of change of the function of h are positive or negative at point I and at point D. Explain your conclusions, okay? So let's mark the 2 points first. There's multiple solutions, once again, so I don't know why they would want to do this. So in pencil, I'll mark this as I, because it's increasing here. I'll mark this as D. Okay, that's totally fine. Increasing here, decreasing there, our function h. So it asks us whether the values of the change in the rate of change of h are positive or negative. Change in the rate of change, that is the concavity. Hope that sounds familiar. Is it concave up or is it concave down at this I that I picked? It's concave down because it's opening downward. Or if you know slope of the tangent line, the slope of the tangent line is above the curve, so it's concave down. Okay? When it's concave down, the rate of change, the change in the rate of change is negative. So this I that I picked is negative. Similarly, at D, the one that I picked here is again concave down. So again, it would be negative, that change in the rate of change. Okay? If I picked different I and D, for example, if I picked this as my I, hopefully you can see the blue on camera, and this as my D, it's decreasing here, right? And it's increasing here. But at this D, it's concave up, so the answer would be positive. And similarly, again, at this I, it's concave up. So again, the change of the rate of change is positive. Okay, so it just depends on the I and D that you pick. So here is the problem with this question. If I picked right at this point, I or D, doesn't matter. In calculus, this is called a point of inflection. The change in the rate of change is 0. So it's neither positive nor negative. So this is the problem with this question. If you pick this point as, actually this is I in this case. This is increasing here, right? That's clear. But at here, the change of the rate of change is 0. So that's not an option that they gave you. So technically you can't pick that point then. But it is a point where it increases, so it satisfies this portion up here. So this is not a good question. Similarly, if I picked over here, D, this is another point of inflection, we call it. So the change of the rate of change, again, is 0. So it's a problematic point again. So they probably did not intend for you to pick those 2 points. But technically, the change of the rate of change is there because the concavity changes at that point. Okay, so hopefully this was helpful.